Hi YouTube, this is Jay Coder back with another stream here, and today we're going to be going over the life cycle of an Android activity, which is pretty important in Android development. And go ahead and subscribe to the channel and comment on this video and like this video. And if you like this sort of thing, and so I'm gonna go ahead and get started shortly with the lesson. I'm going to go ahead and post this collab to the chat so that people can be able to follow along. And like always, I also post it in the description as well. And we're going over a collab directly from the Android developer site so that we can be up to date with the best practices. And so, yeah, today we're going to be working in Android Studio, and also there's going to be some starter code that we need as well for today. So let me go ahead and actually mute this music, and without further ado, let me go ahead and get started with the code lab that I want to go over for today. Well, number one, welcome. Introduction. In this code lab, you learn more about a fundamental part of Android, the activity. The activity is the set of states an activity can be. The activity lifecycle is the set of states an activity can be in during its lifetime. So, this is one of the key components of Android. So, if I were you, I would really pay attention on this lesson because the activity life cycle is quite important. The life cycle extends from when the activity is initially created to when it is destroyed, and the destroyer reclaims that activity's resources as a user navigates between activities in your app and into and out of your app. Those activities each transition between different states in the activity lifecycle. As an Android developer, you need to understand the activity lifecycle. If your activities do not correctly respond to lifecycle state changes, your app could generate strange bugs, confusing behaviors for your users, or use too many Android system resources. Understanding the Android lifecycle and responding correctly to lifecycle state changes is critical to being a good Android citizen. What you should already know what an activity is and how to create one in your app, what the activities on create method does, and the kind of operations that are performed in that method, and what you'll learn how to print logging information to Logcat, the basics of the activity lifecycle, and the callbacks that are invoked when the activity makes moves between states, how to override lifecycle callback methods to perform operations at different times in the activity lifecycle, and what you'll do. Modify a starter app called Dessert Clicker to add logging information that's displayed in the logcat. Override lifecycle callback methods and log changes to the activity state. Run the app and note the logging information that appears as the activity is started, stopped, and resumed. Implement the on save instance state method to retain app data that may be lost if the device if the device configuration changes. Add code to explore that data when the app starts again. 2. App overview. In this code lab, you work with a starter app called Dessert Clicker. In this app, each time the user taps a dessert on the screen, the app purchases the dessert of the user. The app updates values in the layout for the number of desserts that were purchased and for the total amount the user spent. This app contains several bugs related to the Android life cycle. For example, in certain circumstances, the app resets the dessert values to zero. Understanding the Android life cycle will help you understand why these problems happen and how to fix them. Get the starter app. So, download the Dessert Clicker starter code and open it in Android Studio. I've already went ahead and done that before the stream, but I'm going to go ahead and get you guys the link so that you all can be able to download the starter app code from GitHub here. All right. So you'll be able to download that from GitHub and to be able to follow along with what we are doing here. And I already got it on my end right now. So this is basically the code, and when we play it, it's going to come up with this, basically that screen. It restarted. All right, so let us go on. And so it says we download and open it in Android Studio. And so it describes how to get it from GitHub. I'll leave that as an exercise to you all. Um, and then so we basically start up the project and run it. And so, number 3, explore the lifecycle methods and add basic logging. Every activity has what it is known as a life cycle. This is an allusion to plant and animal life cycles. Like the life cycle of this butterfly, the different states of the butterfly show its growth from birth to fully formed adult to death. So, fully formed adult to death. Similarly, the activity life cycle is made up of the different states that an activity can go through, from when the activity is first initialized to when it's finally destroyed and its memory reclaimed by the system. As the user starts your app, navigate between activities, navigate inside and outside of your app, the activity change state. The diagram below shows all the activity lifecycle states. As their names indicate, these states represent the status of the activity. The activity lifecycle: resume, started, created, initialized, destroyed. Often, when you want to change some behavior or run some code when the activity lifecycle state changes, therefore the activity class itself and any subclasses activity such as app compact activity implement a set of lifecycle callback methods. Android invokes these callbacks when the activity moves from one state to another, and you can override these methods in your own activities to perform tasks in response to those lifecycle state changes. The following diagram shows the lifecycle states along with the available overridable callbacks. So, resumed, and then started, created, initialized, destroyed. And it's important to know when these callbacks are invoked what to do in each callback method. But both of these diagrams are complex and can be confusing. In this code lab, instead of just reading what each state and callback means, you are going to do some detective work and build your understanding of what's going on. Step 1. Examine the onCreate method and add logging. The configure To figure out what's going on with Android Lifecycle, it's helpful to know when the various lifecycle methods are called. This will help you hunt where things are going wrong in Desert Clicker. A simple way to do that is to use Android logging functionality. Logging enables you to write short messages to a console while the app runs, and you can use it to show you when different callbacks are triggered. 1. Run the Desert Clicker app and tap several times on the picture of the dessert and note how the values for the desserts sold and the total dollar amount changes. Open main activity.kt and examine the onCreate method for this activity. So when we click this, actually it's not clicking. um, Let me see. Let me restart this really quick. I don't think it's really responding right now. Let me restart this real quick. So basically I can click on these this middle image and it will cycle through these desserts, and right now I racked up $600 in desserts. But you keep clicking these, and then when they're sold out, it'll show you the next dessert special. So right now I bought $925 worth of desserts, and now it wants us to open the main activity and examine the onCreate method for this activity. For this, so basically, we're going to go in our main activity, which is usually in our Java, inside main activity, and then we are going to go into our onCreate method, and then alright, so it wanted us to go to our onCreate method, and then what does it want us to do? In the activity lifecycle diagram, you may have recognized the onCreate method because you've used this callback before. It's the one method every activity must implement. The onCreate method is where you should do any one-time initializations for your activity. For example, in onCreate, you inflate the layout, define click listeners, or set up view binding. The onCreate lifecycle method is called just after the activity is initialized. When the new activity object is created in memory, after onCreate executes, the activity is considered created. So these are the methods inside the activity: the onCreate, the on start, on restart, on create, on pause, on stop, on destroy, on resume. And so we're talking about the on create right now. And then inside the on create actual method, what are we doing here? We're setting up our binding, and we are pretty much initializing our different things, like the revenue and the dessert sold and setting the image. So it's kind of our first initialization setup. Then we're setting the click listener here. So yeah, that's the kind of stuff we do inside the onCreate method, and that's inside our activity here. And note, when you override the onCreate method, you must call the superclass implementation to complete the creation of the activity. So within it, you must immediately call super.onCreate. This this same is true for other lifecycle callback methods. In the onCreate method, just after the call to super.onCreate, add the following line. Just after the super onCreate, add the following line. So I'm going to add the following line after the super.onCreate. So let's go to our Android Studio, and there's a super.onCreate. Right after the super.onCreate, I'm going to add this log method. Then I'm going to include the import that we need. And so here we're going to indicate onCreate is called. So onCreate is called. And then we imported the log, uh, the log dependency. The log class writes messages to the log cat. The log cat is the console for logging messages. Messages from Android about your app appear here, including the messages you explicitly send to the log with the log.d method or other log class methods. There are three parts to this command. The priority of the log message, that is how important the message is. In this case, the log.d method writes a debug message. Other methods in the log class include log.i for informational messages, log.e for errors, log.w for warnings, and log.v for verbose messages. The log tag, the first parameter in this case, main activity, the tag is a string that lets you more easily find your messages in the logcat. The stage is typically the name of the class. The actual log message, the second parameter, is a short string, which in this case is onCreate called. Note, a good convention is to declare a tag constant in your class. Constant val tag equals main activity, and use that in a subsequent calls to log methods like below. Log.d tag onCreate called. A compile time constant is a value that won't change. Use constant before the variable declaration to mark it as compile time constant. Compile and run the dessert clicker app, and you don't see any behavior differences in the app when you tap the dessert. In Android Studio, at the bottom of the screen, click the Logcat tab. In the Logcat window, type the d slash main activity. So it wants us to go ahead and run the app, and we are going to type in the main activity here. So when we go ahead and go to the Android Studio, then inside the Android Studio, we have this main activity as the tag here, and then it wants us to go to our logcat and to filter the main activity. I thought I copied it here. Let me copy it. So we copy this and then we put this in our filter here, which is going to be our main activity. So right now we're going to restart the application and then we're going to start it again by playing it right there. And then once it's played, we're looking for when the on create is called. All right, it's launched successful, and so it took us back to this run tab. So we actually have to go back to the logcat tab, and then inside the logcat tab, we do see that the on create was called. So it only takes a few seconds because it only takes a few seconds for the app to load. So that's what they want us to see is the on crate was called. And so let's go back. And then it says the logcat can contain many messages, most of which aren't useful to you. You can filter the logcat entries in many ways. By searching is the easiest because you use main activity as the log tag in your code. You can use that tag to filter the log. Adding d slash at the start means that this is a debug message created by logd. Your log messages include the date and the time, the name of the package. Your log tag with d slash at the start and the actual message, because the message appears in the log, you know that on create has been executed. Implement the on start method. The on start Lifecycle method is called just after the on create. After on start runs, your activity is visible on the screen. Unlike on create, which is called only once to initialize your activity, on start can be called many times in the lifecycle of your activity. Note that the on start is paired with corresponding on stop lifecycle method. If the user starts your app and then returns to the device's home screen, the activity is stopped and is no longer visible on screen. In Android Studio with main activity open and the cursor within the main activity class, so select code override methods or press Control O on Mac. A dialog appears with a huge list of all the methods you can override in the class. Start entering on start to search for the right method. To scroll to the next matching item, use the down arrow. Choose on start from the list. So there's on start right there. From the list, add the OK to insert the boilerplate override code. The code looks like this. So the code looks like that. And so it says you can go to main activity class, code, override methods, or press Control O or Command O, and the dialog box appears. So I can go to my Android Studio, and then it says I can go to Command O. Wait a minute. What? Command O. Uh, huh. Okay. So it says code override methods. And actually, let me see. It's actually Control Control O for Mac, and then it wants us to select the on start. So on start method, which it was on start, right? On start method, and we are searching for the on start method. All right. Okay. All right. So the on start is there. So here's the on start. So we're gonna hit OK, and then it adds the on start here to our main activity. Then it will probably want us to add another log there. Start entering the on start, and so we added the on start there. Inside the on start, add the messaging log. So we're gonna add this log to our on start. So, all right, there's our messaging log. And this is our tag. We're going to, they want our tag to be main activity. So we'll go ahead and make this inside our here. Which will be our main activity. And then inside our on start, we will have our tag here. And then it probably wants us to compile and run the desired clicker app and open the logcat panel. Type this into the search field to filter the log. Notice that both the onCreate and onStart methods were called one after the other, and that your activity is visible on screen. Press the home button on the device and then use the recent screen to return to the activity. Notice that the activity resumes where it left off with all the same values, and that the onStart is logged a second time to logcat. Notice also that the onCreate method is usually not called again. So what they are talking about is when we go back to our app, and then what we're going to do is we're going to stop the app, and then we're going to restart the app. And then once we restart the app, we will see the methods being called, and then we have to go to our logcat. And then inside our logcat, we see that our two methods are called, the onCreate and onCalled. Actually, I can paste this in, which is narrowing it and filtering it down to our, well, actually, it doesn't want to do it in this browser. But anyway, our this IDE. On this, it says onCreate and onStart. Alright, so it said hit the home button. So the home button, it would be the circle, right? Inside Android. So I'm going to go ahead and hit the home button. And then it took me out of the app. And then I want to go back to the app, which, let me see. Alright, I'm going to go back to the app, which one was our app? The dessert. So that's our app. And then it wanted us to notice. Once we went back to our app, it called the onStart again. It did not call the onCreate. So it only did the onCreate on the initial start of our app. And then when we went to our home screen, it paused, and then when we came back to the app, the only thing it called is on start and not the on create. So that's the thing they wanted us to see so far. Okay, so let us move on. And so now, since we saw that, as you experiment with your device and observe the lifecycle callbacks, you might notice unusual behavior when you rotate your device. You'll learn about the behavior later in this code lab. In this step, you implement logging for all the other lifecycle methods. Override the remainder of the lifecycle methods in the main activity and add log statements for each one. Here's the code. So basically, what we're going to do is we're going to add log statements for each one, instead of just the on start and on create. We're going to add these ones as well, which are already the built-in lifecycle methods, where we are adding log information to them. So basically, it wants us to see the order of when these methods are called. So I'm going to go ahead and add these under the onStart. So I added them under the onStart. So there's the on resume, on pause, on stop, on destroy, on restart. So now they want us to compile and run the dessert clicker again and examine the log cat. This time, notice that in addition to on create and on start, there's a long message for the on resume lifecycle callback. Alright, so let's go ahead, and this time let us go ahead and go to our Android Studio, and then we're going to stop, and then we're going to start the app again, and then we're going to observe our logcat, which we observe our logcat here, and then so we notice down here that on create was called, on start, on create, on start, on resume was called. And that's the order that it's called at, where create is first, start is second, resume is third. And now it says that when an activity starts from scratch, you see all three of these lifecycle callbacks called in order: on create, on start, on resume. To create the app, to start it and make it visible on the screen, to give the activity focus and make it ready for the user to interact with it. Despite the name, the on resume method is called at startup, even if there is nothing to resume. Now that the dessert clicker app is set up for logging, you're ready to start using the app in numerous ways and ready to explore how the lifecycle callbacks are triggered in response to those uses. Use case 1, opening and closing the activity. You start with the most basic use case, which is to start your app for the first time, then close the app down completely. Compile and run the dessert clicker app if it's not already running. As you've seen, the onCreate and onStart and onResume callbacks are called when the activity starts for the first time. Tap the cupcake a few times. So, okay, so it wants us to go ahead and compile and run the dessert app if it is not already running. And you've seen the onCreate, onStart, and onResume. And then it says tap the cupcake a few times and then tap the back button on the device. Notice the on pause, on stop, and on destroy. So let us go back to the app and also go back to our logcat in our Android Studio. And then once we are here, we're going to click the cupcake a few times. And then after we click the cupcake a few times, it told us to hit the back button on the device. So the back button on the device on our emulator would be this one. So we hit the back button on the emulator, and that took us to the home screen. And then once we did that, our app called these two methods, the on pause and then on stop. So it's paused and stopped right now, our app. So says on pause, on stop, and on destroyed are called in that order. In our case, it didn't destroy ours, which, yeah, in ours it did not call on destroy. So our app is not destroyed right now unless I close it, which let me see. Let me see if I close it. Alright, I closed it. Now the on destroyed was called here. Alright. But I had to close it manually. For some reason, when they hit the back button, theirs was destroyed, I guess. In this case, using the back button causes the activity to be entirely closed. The execution of the onDestroy method means that the activity was fully shut down and can be garbage collected. Garbage collection refers to the automatic cleanup of objects that you'll no longer use. After onDestroy is called, the system knows that those resources are discardable and it starts cleaning up that memory. Your activity may also be completely shut down if your code manually calls the activity's finish method. If the user force quits the app, for example, the user can force quit or close the app in the recent screen. The Android system may also shut down your activity on its own if your app has not been on screen for a long time. Android does this to preserve battery, to allow the app's resources to be used by other apps. Return to the Dessert Clicker app by finding all open apps in the overview screen. Note that this is also known as the Recents screen or Recent Apps. Here's the logcat. So So on destroy called, on start, on resume. So we're going to open the app again. And then our app is this dessert app right here. And then, of course, we have to open our Android Studio and scroll down to the latest. And on create, on start, on resume was called. So okay, they the key point here is that on create and on destroy are only called once during the life cycle of a single activity instance. On create to initialize that for the very first time. On destroy to clean up the resources used by your app. So on create is like on born, and on destroy is like on died or on dead. The on create method is an important step. This is where all your first time initialization goes, where you set up the layout of the first time for the first time by inflating it, where you initialize your variables. Use case 2. Navigate away from and back to the activity. Now that you've started the app and completely closed it, you've seen most of the lifecycle states for when the activity gets created for the first time. You've also seen all the lifecycle states that the activity goes through when it gets completely shut down and destroyed. But as users interact with their Android devices, they switch between apps, return home, and start new apps, and handle interruptions by other activities such as phone calls. Your activity does not close down entirely every time the user navigates away from the activity. When your activity is no longer visible on screen, this is known as putting the activity into the background. The opposite of this is when the activity is in the foreground or on screen. When the user returns to your app, that same activity is restarted and becomes visible again. This part of the life cycle is called the app's visible life cycle. When your app is in the background, it generally should not be actively running. To preserve system resources and battery life, you use the activity lifecycle and its callbacks to know when your app is moving to the background so that you can pause any ongoing operations. Then you restart the operations when your app comes into the foreground. In this step, you look at the activity lifecycle when the app goes into the background and returns again to the foreground. With the dessert clicker app running, click the cupcake a few times, press the home button on your device, and observe the log cat. Returning to the home screen puts your app into the background rather than shutting down the app altogether. Notice the on pause method and on stop methods are called, but on destroyed is not called. So so basically when you hit the home button and go to your Android Studio and then go to your logcat, you will notice that The on pause and on stop is called, but not the on destroy, because the app is not destroyed yet. It's paused. So here we go. When on pause is called, the app is no longer has focus. After on stop, the app is no longer visible on the screen. Although the activity has been stopped, the activity object is still in memory in the background. The activity has not been destroyed. The user might return to the app, so Android keeps your activity resources around. Use the recents screen to return to the app and notice in Logcat that the activity is restarted with the on start and on restart, on start, and on resume. So when we go back to the app, then once we go back to the app and go to our Android Studio and go down to the latest logs, we do see that when we return to the app, it called the on start. The on restart, on start, and on resume. So on restart, on start, and on resume when we return to the app. And when the activity returns to the foreground, the onCreate method is not called again. The activity object was not destroyed, so it doesn't need to be created again. Instead of onCreate, the onRestart method is called. Notice that this time, when the activity returns to the foreground, the dessert sold number is retained. So basically, when we add a few of these and then go to home and then go back, or we could go that way or we could go this way, we see the 20 is there in our recent memory. When when the activity returns to the foreground, the onCreate method is not called again. The activity object was not destroyed, so it doesn't need to be created again. Instead, onCreate and the onRestart method is called. That this time, when the activity returns to the foreground, the desserts number is retained. Start at least one app other than Dessert Clicker so that the device has a few apps in the recent screen. Bring up the recent screen and open another recent activity. Then go back to recent apps and bring Dessert Clicker back to the foreground. So it says to go ahead and open another app, or a couple other apps, I think. And then, so the Dogglers app, okay. And then, what else do we want? The Dogglers, okay. And then, what else do we want? Then the Affirmations app. Okay, we have those two open. And then it says so let's go back to our previous app and let us see what it's called. So we're going to scroll down to the bottom. Then when we call it again, we see that the on restart, on start, on resume, on restart, on start, on resume is called because the destroyed still was not called. So what about on start? The on start method is called like on create. Either on create or on restart is called before the activity becomes visible. On create method is called only the first time, and on restart is called after that. The on restart method is a place to put code that you only want to call if your activity is not being started for the first time. Use case 3 Use case 3, partially hide the activity. You've learned that when an app is started and on start is called, the app becomes visible on the screen. When the app is resumed and on resume is called, the app gains the user focus. That is, the user can interact with the app. The part of the lifecycle in which the app is fully on screen and has user focus is called interactive lifecycle. When the app goes into the background, the focus is lost after on pause, and the app is no longer visible after on stop. The difference between focus and visibility is important because it is possible for an activity to be partially visible on the screen but not have the user focus. In this step, you look at the one case where an activity is partially visible but doesn't have user focus. 1. With the Dessert Clicker app running, click the share button in the top right of the screen. The sharing activity appears in the lower half of the screen, but the activity is still visible in the top half. Examine logcat and note that only on pause was called. So when we go back to our app, then we go back to our Android Studio, and then when we go to our share, it did the on pause. It did not do the stop because only partial part of the screen is covered. And then when we go back, it just called the on resume because it did not have to call the on restart because it was only paused and not stopped. Okay. Says examine logcat and note that only on pause is called. In this use case, on stop is not called because the activity is still partially visible, but the activity does not have a user focus, and the user can't interact with it. The share activity that's in the foreground has the user focus. Why is this difference important? The interpretation with only on pause usually lasts a short time before returning to your activity or navigating to another activity or app. You generally want to keep updating the UI so the rest of your app doesn't appear to freeze. Whatever code runs in on pause blocks other things from displaying, so keep the code in on pause lightweight. For example, if a phone call comes in, the code in on pause may delay the incoming call notification. Click outside the share dialog to return to the app and notice that the on resume is called. Both on resume and on pause have to do with focus. The on resume method is called when the activity has focus, and on pause is called when the activity loses focus. Explore configuration changes. So So, okay, we're going to go ahead and save this portion for next time. And I'm going to say thanks for watching this tutorial. And if you like this kind of content, please go ahead and subscribe to this channel. And so, yeah, we've been going over the activity lifecycle of an Android app. And stay tuned for when we wrap up this lesson on the next stream. Thanks, you guys, so much for watching, and always stay coding.